What's up, YouTube? How you doing? How are you guys? I want to talk about the double slit experiment again. We're back with this one because I don't have it all yet, but I'm very close. I'm gonna make the actual video soon, but at the moment I have this to show you first. So let's look at light and how light acts for just a second. Let's pay attention to how light acts. So, like, undirected light goes everywhere, right? All directions, right? Undirected, unaided, full 360 coverage, right? And we'll go to a flashlight. Got an LED flashlight. See, it's LED in there, but it's very reflective in here, and it's got one direction to go. You know, it has one escape route, and it's very reflective, so that it's ambient and goes everywhere, right? Because it's a flashlight. You want it to light up a large area, right? So, like, it's very wide, right? It's quite a large coverage because the hole it's given is large. Smaller flashlights just won't work. This one doesn't work. That's fine. It'd be the same thing but smaller. the the laser. I have the battery taken out so that I don't accidentally blind myself or you while I show this. So inside of a laser, it's kind of the same concept, but it's really tiny, right? But it's even smaller, right? So let's take the lens off and let's look at, I don't know the actual word, the crystal, the actual piece in here. Can you see that, the round thing there? And then it's round here, and then it's got see where it's reflective and a little pearlescent there. So it's got the see, it's kind of it's clear. That's where it comes out of. That's what's focusing it, right? So that it's really tiny, right? So it's really small, right? So let's look at the laser. So the laser is really small, right? It's a big bright blob on the camera, but it's when you I measured the size of the little hole there where it comes out of, and it was 1.5 millimeters, 1.5 millimeters. So we're getting like we're getting a beam here that's if you can see it, there it is. If you can see it, blind anybody. A millimeter and a half plus ambience. So we have to include the ambience, right? So a millimeter and a half beam plus ambience, and then superluminescence there wherever it makes contact on something, right? Because of how strong it is, because of how strong the laser is. So I have my experiment. I have my double slit experiment. I have my double slit. I measured it. Each slit, both slits are 1 millimeter wide each. We have a 1.5 millimeter beam. This is important. And two 1 millimeter holes. That means a hole that is smaller than the beam that is coming out. Let me reinforce, because I just realized I didn't actually show you the measurement for the camera. We're talking about the center ring, not the. So I showed you that it's a little crystal thing, right? And it's like a ring, and then we're measuring the center, that center ring there. We're measuring that center ring. So we want. You see, it is very tiny. It's a millimeter and a half. It's a millimeter and a half. So when you shine the beam, and the my divider here, the space between the two holes is also 1 millimeter. So I have a 3 millimeter width of coverage here, right? I'm willing to bet 1 millimeter is a lot bigger than you expected. But that's what 1 millimeter. This is what 1 millimeter looks like. This is what 2 1 millimeters looks like. So with a 1 millimeter space between them, so 3 millimeters wide, right? So I drew it out, and I drew it out with a ruler so that it's mathematical, angled, and proper. So here's the beam, right? So here's our beam, our 1 millimeter, 1.5 millimeter beam. I scaled it up is what I did. So to scale it up, you scale it up by 10. So I've got a 1.5 centimeter beam here, 1.5 centimeter. So here's the little, here's the width of the crystal here, shooting out this way, right? This little square represents the crystal from the side, shooting out this way. If you saw it from the front, it would actually be a circle, but this is a top view, shooting out a 1.5 centimeter beam to represent the 1.5 millimeter beam. Like this. And then, so when you show this with the two holes, see, I've got this is to represent the piece of paper, and then the two holes, right? Two holes. And each of these is 1 centimeter wide. So this is a 3 centimeter wide space right here, from here to here. I'll show you again, just to show that I'm not. There's 3 centimeters. I just want you guys to know that I'm not fooling anyone. I'm not bluffing any numbers. There's the 1.5 centimeter beam, and it is also 1.5 centimeters on this side as well. There it is. Wait, there it is. There we go. 1.5 centimeters. Okay. So when you shoot the line out, you see you've got it goes right through here, and it hits the center piece of paper, right? But it's wider than the center piece of paper, right? The beam itself, without any ambience or anything, is wider than that 1 millimeter. I'm suspecting that the other lasers are like this as well. That the other lasers are also probably 1.5 or slightly over 1 millimeter, plus ambience. So when that happens, you get. I'm not including ambience in this drawing because that's too complicated. That's too. That's beyond me. That's beyond me to do because ambience require it would be so tedious. It would be too much. It'd be too much. But like, so it splits, right? It hits that centerpiece and splits into the two and makes the 2 points on the back, right? So as much ambience as I could really include, because this is how light acts as a when it's free, unguided, and it becomes technically free and unguided when it leaves that lens, when it leaves the laser. When it leaves the laser, it is only directed outward from the laser. Understand that. It is light. It is chaos, okay? That's why you have to direct it. It is chaos that goes in a straight line in all directions simultaneously. Which means that there is light that's going to be filling out the rest of these holes. And because of that, because of the way light behaves, since it travels in a straight line, you have to take it from all points of the limit of where it started, right here. So you take it from this side, and you go, follow me here, and you go to the edge, the left edge of this first, of the left edge of the left hole, right? From the left side of the lens. Then you go to the right side of the right hole from the right side of the lens. And you see it points inward, and it makes a spot on the wall back here that is smaller than the 1 centimeter gap in the hole. That is because the size of the laser is bigger than the hole. So, just because of natural ambience and because of the fact that light travels in a straight line, they in the double slit experiment, they need to show you more. They need to show you more than what they're showing you in order to claim what they claim. So in order to claim what they claim, so like I did this with straight lines, right? This was just with straight lines, no waves factored in, and no ambience other than this natural ambience that would create the 2 holes. See that? Doing it with a flashlight helped figure this out. Because it's bigger, it's larger, you blow it up, right? This is really small. This is really big. You blow it up. And you can use the same size holes to do it. point is, whatever laser you see them using in any video, actually you could probably factor in the size of this hole that it's coming out of as well, not just the crystal inside, but because again, light is chaos. It travels in a straight line in every direction simultaneously, and it let me show you the basic way light works. So if you've got a light source, hold on, next part.